Okay, so how many of you are, fearful about recursion? You can just be honest and tell me. So how many of you, when you see a recursive code, it becomes tough for you to realize how is it working? Okay, so today I am just going to have one particular aim for this class, and that aim is that you should lose your fear for recursion. Okay, and I'll try to explain you recursion in different manners, so that given any recursive code, you will not need help of a third person to make you understand that, hey, this is how it is working. You can yourself understand that, hey, this is the way call flows, this is how it will terminate, and this is what the output will be for any recursive code. This was a simple one, but let us complicate it a bit, and then let's say how many of you can figure that out. So I'm going to take another simple example. So let's say there is a void function. Void function means what? It is not going to return anything, okay, but it takes an argument, and it first prints the value whatever it gets, and then it has a condition that if x is greater than equal to 3, it will simply return. So see, in case of void function, you can put return semicolon. The return semicolon is equivalent to exit. It simply means that, hey, exit. Don't return anything but exit. The function should now no more call itself again. It should simply become over. This is the meaning of return semicolon, because there is no exit keyword in C and C++. Okay. Yeah. After this, let's say there are two more lines of code which are like func of x plus 1 and func of x plus 2. Yeah. Now, let us say that I am breaking these into some instructions. Let us say that this was my instruction number 1, this was my instruction 2, this was instruction 3, and this was instruction 4. You will understand why I have done this. Okay. Now let's say there was a main function below it, and from this main function I have invoked that function. So I called func of 0. Okay. Now, another thing that I want all of you to understand over here is that in every recursive code, there are 3 important things to understand, and those are also called as 3 principles of recursion. What are the 3 principles of recursion? First principle is initialization. Initialization means what is the first function call which triggered the recursive chain. So in this case, what should be the initialization? The initialization should be func of 0, because func of 0 is going to trigger the entire recursive chain. So this particular thing is your initialization, right? Second thing is your termination condition. So here you can say that this thing is your termination condition. And then the last thing is your recurrence relation. Recurrence relation means that how your function calls the other functions. So these are the 3 parts of it. Initialization means what is the first function call for which which actually triggered the entire recursive chain. Termination condition means for what values are you going to simply terminate, and recurrence relation means that how a function calls other sub functions. Okay. You can detect these 3 things in the previous code. Can you detect it in the last code that I wrote of factorial? Right? So what would be the initialization condition over there in that factorial code? The first call from the main function, which was for fact of 5. That would be the initialization. Yes. And what would be the termination condition? The if condition, which says that if n is smaller than 0, then you return, if n is equal to 0, then return 1. That would be termination condition. And recurrence relation will be return n into fact of n minus 1. Okay, great. So take a look at this code. I want you to predict the output of this code. Okay, just predict the output of this code. So everyone take your time, use your pen and paper. Okay, so let us understand how to decipher the output of recursive code in a very easy manner. Okay, so see, if you take a look at this code, what does it say? It says that, hey, I'll make 2 function calls. I'll invoke func of x plus 1 and then I'll invoke func of x plus 2. Now you tell me one thing, will it ever happen that both of them are getting executed concurrently or parallelly? Will it happen? That is not the way it happens, right? So what will happen? Until unless this is not over, this will not even start, isn't it? Until unless the first instruction is over, the second instruction will not start. Only when the first instruction is completely over, you will move on to the next instruction. If you understand this thing, then things are not tough for you. And now how to make a mental map of it very clearly, that I am going to tell you. So a way to do that is using such kind of diagram. So see, first call was for func of 0. So I am going to model it as f of 0. Now, what this f of 0 is going to do, I am going to just mention them one by one. Okay. So first it is going to print a value 0. So this is guaranteed that 0 will be printed first. Only once the 0 is printed, then the call will hit f of 1, and only when the f of 1 has finished completely, then the f of 2 will start. Now this thing I am just simply going to model. So 0 has been printed, now the call to f of 1 will be made, and once it will be completely over, then only I will migrate to f of 2, right? Now what will happen? Now forget about this. This is like in a waiting room. This is waiting for this to entirely get over. So now you are at f of 1. So now you are at f of 1. So what will this do first? What will f of 1 do first? Just look at the code and tell. Look at the func for x equals to 1. What is the first thing it does? It prints the value 1, right? So first it will print the value 1. What is the next thing that it will do? Will the if condition be true for this value of x, which is 1? No, it will not be true. So it will come to below and it will say that, hey, invoke f of 1 plus 1, which is f of 2. And once this is over, then only it will move on to f of 3, right? So see, this f of 2, which was waiting for this to get over, now this will wait for this also to get over and this also to get over, isn't it? Because f of 2 and f of 3 are nothing but those are children of f of 1, right? F of 1 getting completed means f of 2 and f of 3 also getting completed. Once they are completed, then only that f of 2 will start, right? Now again, first this thing is going to explode. So how is this going to explode? It will first print the value that is 2. And then what will happen? This if condition will be false and it will come here and it will make call for f of 3. And once this is over, then only it will go to f of 4. Now see, again, you are seeing, no, this thing is waiting for this to get over, right? Now what will happen? This f of 3 will get executed. So what will this do? For f of 3, this print condition will get executed. And will this if condition be true or not for this value? It will be true. Yeah, it will be true. So it says return. What does the return mean? Return simply means that, hey, now this will exit. Now this will simply exit. Now whenever this exits, what is it that should happen? So let's say there is a parent. In this case, this is a parent. Parent executed instruction 1. I'm just naming them. Then instruction 2. Instruction 2 was a function call. Whenever this function call gets over, where should the control return back? Should it directly go to F4? So basically, if we try to be more technical, first it will go to the immediate parent. Yes. That is what happens. If main function calls a function func, whenever func gets over, control comes back to main function and then main function executes the next lines of code. So that is exactly going to happen here also, right? Because for f of 2, when f of 3, which was a child, when it has got over, then what will happen? Control comes here and then this will call for f of 4. So the next execution will happen for f of 4. And now what will happen? That f of 4 will print 4 and then this will also return, right? So f of 4 has also returned. So again, when this is returned, control comes here. Now this is over. F of 2 is entirely over. So now the control goes to this and this calls its next child, which is f of 3. Now what this f of 3 will do? This f of 3 will again, firstly it will print 3 and then based on this, it will also return. This returning means control goes here. Now this has no other instructions to execute, so this is also over. So the control goes here. Now it invokes its child, which is f of 2. Now don't you think so that this f of 2 will explode in exactly the same way in which this thing has exploded, right? So that is exactly what will happen over there also. If you take a look, you are at f of 2, and the same logic will be applied. First you print 2, and then what you do? You call f of 3, and then you call f of 4. F of 3, what happens first? You print 3, and then based on this you return, and then the same thing over here. So that's it. So the first value to get printed was 0, and then 1, and then 2, then 3, then 4, then 3, then 2, then 3, then 4. 0, 1, 2, 3, 4, 3, 2, 3, 4. That's it. So this way you can very easily predict the output of any recursive code. And this is also called as recursion tree diagram. Because this is just like a tree where every caller is thought of as a parent, and then the functions that have been called by it are thought of as a children. And first this child will be executed, then this child, and so on and on. So this way, given any function, you can create this recursion tree diagram and you can predict the output in a very easy manner. So now can you all predict the output of any damn recursive code, any random recursive code that I give? No matter how many calls it is going to trigger, can you draw this diagram and predict the output? Very easy, right? You just have to start from the first call, make the calls and execute them in the right manner. You know where you have to go to, like when this is over, you know where you have to go to. And same thing here, when this is over, you know where you have to go to. When this is over, you know where you have to go to. When this is over, you again know where you have to go to. That is the reason. So drawing this kind of diagram tells your mind clearly that, hey, whenever this is over and you return to the parent, which instruction should next be executed by that parent? You know, because you drew that initially. That is the reason this kind of diagram is very, very helpful. Are you getting a sense of it or not? That why is it so that this diagram is being helpful to me? So although I will always recommend you to use this kind of recursion tree diagram to predict the output, because this is very, very fast. If you draw this, in a very fast manner you say that, hey, this is what the output is going to look like. Okay. And see, another way of looking at this is, see, the first call was for func of 0. And just look at three things. Look at the print, which is this. And then look at func of 1. Func of 1 is this entire thing. Okay. And func of 2 is this entire thing. Okay. That is how it has happened. So func of 1, when it happened completely, happening of this means printing of these things. Then only this happened. Now again, the same thing, that the logic you are applying at f of 0 level, you can apply at f of 1 level also. That first it printed this, and then it made entire f of 2 happen, and then it made entire f of 3 happen. So that is the way recursive definition of things are, that whatever is happening at this node will happen at other nodes also, until unless that is a terminal node. If it is a terminal node, then maybe just printing will happen and then the other calls will not happen. Okay.